we shall take differentiation of a function which is given in parametric representation. Differentiation of a function given in parametric representation. That means if a complicated function is there, if that is written in a simplified form, x as a function of t and y also a function of t, where t is called the parametric representation, then how to find out dy by dx. If x is equal to f of t, g is equal to, no, y is equal to g of t, where t is the parameter, then if delta t is a small change in t and delta x comma delta y are the corresponding changes in x and y. That means x and y depend upon the parameter t. If there is a change in t, there will be a change in x. If there is a change in t, there is a change in y. Consider delta y by delta x. That means small change in y by small change in x. You divide numerator and denominator by small change in t. Delta y by delta t by delta x by delta t. Now as small change, that is what delta t tends to 0, delta x also tends to 0, because there is a change in t, there is a change in x. So left hand side you take limit as delta x tends to 0, right hand side in the numerator and denominator you take limit delta t tending to 0. Limit delta y by delta x tending to 0 in the left hand side, whereas in the left hand side without loss of generality you can take limit delta t tends to 0, because delta x tends to 0, delta t tends to 0. So delta y by delta t divided by delta x by delta t. Now by usual notation, left hand side becomes dy by dx. So dy by dx is equal to, numerator becomes by same notation dy by dt. And denominator is what? Dx by dt. Dx by dt. So this is the formula for differentiation of equations given in parametric representation. Now we shall take problems where we have to find out dy by dx if the functions are given in parametric representation. So find dy by dx. First problem, find dy by dx if x is equal to a cos t, y is equal to a sin t. It represents a circle. Remember, this represents circle x square plus y square is equal to a square. Its parametric representation is given. Now, find out dx by dt separately, because x is a function of t. So, minus a sin t. Now, find out dy by dt. Differentiation of y with respect to t, it is sin t, so it becomes a cos t. But what we want is dy by dx. Dy by dx is equal to the formula I write for some time, dy by dt by dx by dt. This is y. So this is equal to dy by dt, not first one by second one by first one. A cos t is the dy by dt, divided by minus a sin t. So a cancels here by trigonometry minus cot t. You can also see when t is equal to pi by 4, minus cot t is nothing but minus cos pi by 4 is what? Minus 1. So later on we shall try to work out problems of that type. Next, number 2. Find dy by dx. Find dy by dx at t is equal to pi by 2. At t is equal to pi by 2 if x is equal to a secant t, y is equal to b tan t. This represents the ellipse. So, not ellipse, it is hyperbola. X is equal to a secant t, y is equal to b tan t. You find out dx by dt. Dx by dt is equal to differentiation of a secant t with respect to t is what? A secant t into tan t. Now dy by dt by the same method is what? B into differentiation of tan t with respect to t is what? Secant squared t. Now what we want? Dy by dx first. Dy by dx is equal to dy by dt by dx by dt. Dy by dt is what? B secant squared t by a secant t tan t. Now this one secant t cancels with this one, and then there remains b by a. Secant t is what? 1 by cos t by tan t is what? Sin t by cos t. Sin t by cos t. So cos t and cancels. 1 by sin t is what? Cosecant t. Now what we want is dy by dx at pi by 2. At pi, t is equal to pi by 2. That means the answer wherever dy by dx, wherever t is there, pi by 2 you put it. Dy by dx is equal to, here b by a is necessary. B by a. So it is equal to b by a cosecant pi by 2. We know cosecant pi by 2 is what? 1. Because sin 90, sin pi by 2 is 1, cosecant pi by 2 is 1. So into 1 is equal to b by a. This is the answer. Sometimes at a different value of t, they will ask dy by dx. Next, we take a rectangular hyperbola, that is, its equation is written like this in the parametric representation. X is equal to ct and y is equal to c by t. It represents rectangular hyperbola because that is what rectangular hyperbola equation is. Xy is equal to c squared. If you put x and value, y value here, you see it becomes c squared. So dx by dt is equal to c into 1 and dy by dt. Here I asked you already to remember, see, differentiation of 1 by t is what? Minus 1 by t squared. That means what? Minus c by t squared. So therefore dy by dt is equal to, every time you write the formula dy by dt by dx by dt, and it is minus c by t squared by c. So c cancels, you get minus 1 by t squared. C, it cancels here. So this is the answer. Okay, number 4, it represents a cycloid. Number 4 is x is equal to a into t plus sin t. T plus sin t, and y is equal to a into 1 minus cos t. So dx by dt, a into differentiation of t with respect to t is what? 1 plus differentiation of sin t with respect to t is what? Cos t. And dy by dt is equal to a into differentiation of only 0 minus cos t is what? Plus sin t. 0 plus sin t. Why? Cos t is minus sin t, into minus is what? Plus sin t. So what we want is dy by dx. Dy by dt by dx by dt. Dx by dt. Dy by dt is what? A sin t by a into 1 plus cos t. Here a cancels. You can leave it here under ordinary circumstances, but as a student of mathematics, you must know how to simplify. Simplification is a must. So 2 sin t by 2 into cos t by 2, you can use the trigonometric formula, and 1 plus cos t is what? 2 cos squared t by 2. Here 2 cancels, 1 cos t by 2 cancels, it becomes only sin t by 2 by cos t by 2, which is tan t by 2.